Hi there, and welcome to my second episode of adding Houdini to your arsenal. This time I will talk about geometry. To be able to alter geometry in Houdini, we need first an object. So lay down a geonode. The geonode is the empty object inside of Houdini. It displays this box here as a dummy geometry, and inside you'll find this file node that is used to import data from your hard drive, but we don't want to do this today, so get rid of it by deleting it. Instead, lay down a grid. This grid node is not an object, it's a geometry generator, so it's creating geometry, and then it passes it on to this output port. As nothing is connected, and the display flag is set to this grid object, the geometry is directly used by this object here and displayed in the viewport. It's a little big, make it smaller, say 1 by 1, and add a little bit more geometry, say 100 by 100 subdivisions to just have more polygons, like so. So now I can do something to my geometry by, for example, appending a mountain. A mountain is a noise-based displacement effect, so it uses noises to displace the geometry that's coming in. If I connect it and then set the display flag, you see the effect the mountain top has. So what's happening here? The grid is creating geometry and then passes it on. It flows downstream here through this wire, and the mountain is reading the geometry and then doing its displacement effect. But the mountain top has no clue about the existence of the grid. It's just that both of them share a common data format. So they have an interface of data, structured data, such that the grid is generating data that the mountain understands. So if I, for example, put down a sphere and switch primitive type to polygon, give it a little more geometry too. This is our sphere here, maybe decrease the radius a little bit, even more geometry. And if I now use the sphere as input, the mountain top happily displaces the sphere. To be able to really make use of the power of Houdini, it is vital to understand this geometry format. So let's take a little detour to explain how the data is structured. So let's see how a 3D program stores geometric data. It uses points, everybody knows that. By using points, we can define locations in space. So if we want to model a surface, let's say this is a surface in the real world, it's continuous, we place points on the surface, and thus we create a set of points with a constraint that they lie on the surface, and so we create a 3D model of the surface. But to do this, we need a lot of points, and a lot of points are costly because they have to be stored in memory. So there is a trick, and the trick is called interpolation. We want to interpolate the positions of the points. To do this, we have to connect them, and we do this by using polygons. So we use points to connect them to form polygons. 3 points or more points form a polygon. And if we have a look at one of these polygons are used to interpolate the positions of the points. That means that every point inside of the polygon can be reached by doing a linear combination of the 3 points or more points that form the polygon. By doing this, we can approximate every surface very cheaply by using few points. But of course, it has a drawback, because if I look to a real-world surface from the side, and I place my sample points by hand or by 3D scanning on the surface, and then connect them to create polygons. You see these polygons are linear, so it's only an approximation. We have a deviation here between the real surface and the approximated surface. Nevertheless, Houdini uses exactly the same approach. It's just that we have to understand how exactly Houdini is managing this data. To define geometry, Houdini uses 3 lists in memory: points, primitives, and vertices. So what are these? Well, points are locations in space. They get an index 0, 1, 2, and these indexes are stored in memory in list, and every entry holds a 3D vector defining the location of the point. primitives are the structures that connect these points. And they are not called polygons because Houdini is capable of dealing with different geometry types, like NURBS or Bezier patches or Kuhn surfaces. And thus primitive just refers to the most primitive entity of geometry. In the case of polygonal geometry, this is a polygon. In the case of NURBS geometry, it's a NURBS patch. But in our case, it's a polygon. And then we have vertices. And don't get confused here. Vertices are not points. Maya uses the term vertex to indicate what Houdini calls a point. But in Houdini, vertices are something very different. They are basically anchors. They are used to connect the primitives to the points. So when we create a polygon, in our case, we just create a new polygon index, 0. Now we have an empty polygon. We have to define how many points make up this polygon. And that is done by using vertices. We append vertices to this polygon. So let's say we create 3 vertices. Then these vertices are appended to this polygon. This polygon contains these vertices now. And these vertices act as anchors for the points. So at the moment we have an empty primitive with 3 corners because the primitive has 3 vertices. So we have a polygon here that is not located in space yet. It's just sitting there in memory. And at the corners it has 3 holes or 3 anchors. So possible places for points to be stored. And these are the vertices. So these are the vertices 0, 1, and 2. Let's color these red, 0, 1, and 2. These are the vertices. And now I can establish a link between the points in space and this structure here in memory by connecting a point to a vertex. So if I now put the index of a point here in the entry of the vertex 0, I associate the point 1 with the vertex 0. So this point goes here. And then I do the same thing with point number 2 for the vertex 1. Then I associate point number 2 with the vertex 1. And I use point number 0 with the vertex 2. Like so. By doing this, I now located this triangle in space. Now that I did this, I created a triangle that actually lives in 3D space. Let's color this. Now this triangle is located here. And by the order of the vertices, I can tell the winding order of this polygon. So it goes 1, 2, 0. So 1, 2, 0. The direction is this way round, from 1 to 2 to 0. And this direction is important because it defines which side of the triangle is inwards and which is outwards, or to which side the normal points. If I do it the other way around, the normal points to the other direction. So this is how Houdini stores geometric information. Fortunately, in Houdini, we have a list that shows us exactly this structure. And this list is called the geometry spreadsheet. Here it is in all its glory. At the moment we have a lot of points, that's why we have a lot of entries here. At the top of this window you find 4 buttons, and these buttons refer to the lists I explained a second ago. The first button is for points, the second one is for vertices, then this one is for primitives, and that one is for detail. More about this later. The point list shows you all the indexes of the points and then a 3-dimensional vector storing the location of the point. The primitives is just a list of primitives, and then you have the vertices. And the vertices have a special index structure. There are 2 indexes divided by a colon. This is the vertex 0 of polygon 0. This is the vertex 1 of polygon 0. This is the vertex 2 of polygon 0. And then you find here the point number. So that is exactly the structure I outlined a second ago. Here you have a nice overview, and you can refer to this view anytime. And as your setups in Houdini get more and more complex, you will refer to this view more and more often. But let's get rid of this mountain thing and do something very basic to understand this better. Put down an add sub. Add sub can be used to create points and polygons. Here on the Points tab, just check point 0 and you get a three-dimensional vector. You can put a number here, and this creates a point. The point is very tiny. It's located here. I don't know if you see it. To see it better, turn on point display and point index display. Then you clearly see here is point 0. If we want to add a second point, we can do this by clicking plus and turning second point on, and we move this in another direction, like for example so, and then a third point, like so. Now we have 3 points in space. And now let's append another add sub, but this time let's add polygons. Here we have number of primitives 1, so we are adding 1 polygon. And now we have to define which points are stored in the vertices of the polygon. And that can be done by just typing the indexes in this field. So let's create a polygon with the order 1, 0, 2. Just put here 1 space 0 space 0 space 2, like so. And we have a polygon. This polygon is at the moment open because Houdini does not make a difference between polylines and closed polygons. It's just a flag that makes a difference, and we can set this flag by clicking this checkbox here. And now we created our very first polygon. If we now have a look at the geometry spreadsheet, it's easier to understand what we see here. So here the point list shows us the 3 vectors we input into these 3 fields. Then the polygon array just shows us 1 polygon, because we created 1 polygon, and this has index 0, and then the vertex list shows us that this polygon 0 has 3 vertices, and they are referring to the points 1, 0, and 2. If I change the order here, say 2, 0, and 1, this change is reflected here, 2, 0, and 1. And look what happens to the normal. I can display normals inside of Houdini by clicking on this button here. That shows me the point or vertex normals, or by clicking this button here, which shows me the primitive normals here in purple. So at the moment the normal is pointing in this direction, and the order is 2, 0, 1. If I reverse the order, 1, 0, 2, the normal is pointing in the other direction. So that is how you create geometry inside of Houdini and how you inspect geometry inside of Houdini. Besides the geometry spreadsheet, there is another possibility to inspect your geometry, and that is middle clicking on a node. If you do that, you get this info window, and this tells you a lot of things about your object. It tells you that this object has 3 points and 1 primitive with 3 vertices, and that this primitive is of type polygon, and the count of polygons is 1, 2, because we only have 1 polygon. This view is very important too. It is often the case that you need more detailed information about an object, and you can find it here. So we learned about geometric data in Houdini, and we learned that points are indexes that are combined with a 3D vector defining the location in space. But fortunately, it does not stop here. In Houdini, there is a very powerful system in place called the attribute system. It is somehow similar to things like vertex maps or vertex weights in other applications, and it is referring to the possibility to store arbitrary data on your points. So you not only can store a location in space on your points, but everything you want. You can create new data channels, if I want to call them like this, and store every data you like in there. For example, you could create a channel called weight and store a float weight between 0 and 1 on every point that you could use later on for weighting a character to conform to bones or something. Or you can define a fall-off, or you can define whatever you like, even strings or arrays or matrices. It really has no restrictions whatsoever. So to understand this better, go 1 level up and create a new geo node. And dive inside, get rid of the file. and lay down a torus. Like so. I turn off all the visualizers. Here is our torus. So at the moment, this torus is composed of points, and these points have locations, but there are no other attributes present. You can change that by using a node called attribute create. Attribute create. Here it is. Append it. And this allows us to create arbitrary attributes. If you are familiar with thinking particles, this is exactly the concept of custom data channels in thinking particles. So adding your own user data to geometric entities. The parameters of this node are a little bit overwhelming at first, but it's really easy. The first thing is that you can specify a name for your attribute you want to create. Let's call ours weight. And then the next important thing is the class, because it is not only possible to store attributes per point, but you can store attributes per vertex or per primitive, or even on detail level. Detail level refers to the geometry as a whole. Let's stick to points for now. The next thing you have to specify is the data type of the attribute to create. Standard is float, but you can really create whatever you like, an integer, a vector, string, float array, whatever. Let's stick to float for now. And then you have the precision, that is just how much memory the variable or the attribute will use. So this should be sufficient for now. Let's have a look at the geometry spreadsheet. And you see we have a new column now called weight. And the value of this weight is 0. If you scroll down, you see it's 0 throughout. And that is due to the default value here and this value field here. The default value is, as the name suggests, the default value for the attribute. So if you don't set it explicitly, it's set to this value. And the value is the value you really want to set. So if I change this to 1, for example, you see I have now ones. So every point has a weight attribute now with the value 1 in it. Why do we have 4 fields here instead of just 1? Well, because the UI is not dynamic. It's just 4 fields because the most fields you will ever use are 4 if you are creating a vector 4. So we have 4 fields, but in the case of a float, only the very first field is used. So cool, now you have created your first attribute. If you go to this view menu here, you see all the attributes that are on the geometry. And we not only have weight and p, which is position, but map, offset, and group attributes, which is a standard internal Houdini thing that is always added. You can middle click on the node and you see the same information here. So in this line here, it states that this geometry has 2 point attributes, p, which is standard and always there, and weight, which we created on our own, and it's of type float. Great. But what can we do with this? Attributes are used to give geometric elements individual values. So to vary values across geometric elements, in our case points. But it's not very useful if all the points just get the same value. So let's lay down another node called attribute randomize. This can be used to set random values to whatever attribute you like. In our case, this attribute is weight, the attribute we just created. And if you now have a look at the geometry spreadsheet, you see that instead of 1, we have a lot of different values, a different value for every point, because this randomize node randomizes all the values of the weight attribute. Now we have an attribute with different values on every point. And we can see this in the geometry spreadsheet. But that is not the only way to visualize the values. We can lay down a visualize node. And this visualize node can turn our attribute values into color, for example. So append it here and make it visible. And it shows us an attribute. The attribute P, because that is the default. Here in the attribute field, that is the attribute to show, it has P. If we change this to weight, the attribute we just created, and then we have to make Houdini update by just making this visible and then this visible again, that's sort of a bug. You see the attribute being visualized as color. And it's currently just used as a red channel. With this color type drop-down, you can state how to visualize the attribute. And ramped attribute is maybe a good idea in our case. And same holds true again. Let's update. And then we see that we have this ramp here. Blue means 0, red means 1. And now you can see the individual values of the points visualized as color. So it's easier to understand what's going on here. And pay attention to another important thing. You not only see the different values of the points, but you see that the polygons are used to not only interpolate the positions of the points, but the attributes. So these color attributes are interpolated over the surface of the polygons, and that's why you have these color gradients here. And that is true for all attributes. So you can use meshes to interpolate point attributes over the surface, which is very useful in many cases. Okay, what can we do with this attribute? We can vary effects on a per point, per primitive, or per vertex basis. So we can specify individual values for individual geometric elements. Let's say we want to do an extrusion on our torus. Lay down a poly extrude and append it here directly to the attribute randomize. The poly extrude node does what you would expect from a poly extrusion. It extrudes the polygons. But this is not done interactively in the viewport. You can do it interactively in the viewport, but you can do it procedurally too, by just altering the parameters. And that is what I want to do. If you change the distance, you get an extrusion. At the moment, everything is extruded as one piece. Because of the divide into is set to connected components, if I set it to individual elements, you see every single poly is extruded. Wouldn't it be nice if I could set the distance to be extruded on a per primitive basis, on a per polygon basis? And I can. But at the moment our attribute, remember, your visualizer, is a point attribute. And the poly extrude expects values on the primitives because the extrusion happens on every primitive. So we have to change that. Go back to the attribute create and change the class from point to primitive. And if you now visualize this, this looks strange because the visualizer thinks of a point attribute. Let's change this to primitive, and the attribute randomize has to be changed to primitive too. Now we create a primitive attribute, we randomize a primitive attribute, and we visualize a primitive attribute. And because of this change, we now have evenly colored faces, because every face has an attribute value now. If we have a look at the geometry spreadsheet real quick, you see that the weight attribute is no longer present in the point list, but now in the primitive list we have a new attribute with a weight value. We changed the class of the attribute from points to primitives. Now we have an individual value between 0 and 1 for every primitive. And we can make use of this on the poly extrude. On the poly extrude node you can go to local control. And local control is exactly for using attributes. I can turn on distance scale, and by putting the attribute to use, weight in my case, you can use the attribute you specified to scale whatever you put here in the distance field. So I still can use this distance field, but the value here is scaled with a value from the attribute that lies between 0 and 1. And although this is a very simple example, you might get an idea about the power that lies in this system, because it's really easy to work with individual geometric components inside of Houdini, which is not the case necessarily in other applications, at least not that easy. So, being able to define individual values per component, you can do a lot of procedural modeling and other procedural setups, because you can exactly tell which values to use for every point, for every primitive, or for every vertex.